Hello everyone, welcome back to another video of our multithreading in Java series. And in this video, we'll be solving the problem zero odd even printer problem. Okay, so let's dive directly into that. What this problem states? This problem states you have to create three threads, namely T1, T2 and T3. T1 should be responsible for printing 0, T2 should be responsible for printing only odd numbers, and T3 should be responsible for printing only even numbers, right? You will also be given a variable named n. For example, suppose the value of n is 5. Then your output should look something like this. First you will have to print 0 using thread T1. Then you will print odd number using thread T2. Then again you will print 0 using T1. Then you will print even number using T3. Then again 0 using T1. Then 3 using T2, 0 using T1, 4 using T3, then 0 using T1 and 5 using T2, right? So this is what you have to do. You have to print odd and even numbers 1, 2, 3, 4, 5. But before you print that number, you have to print 0, right? So 0, then odd, then 0, then even, then 0, then odd, 0, even, 0, odd. So on till n equals to whatever value you are given. Here n is equal to 5, right? So I hope problem is clear. Now you can solve this problem using various methods, using wait notify, using semaphores as well. But we will be solving this using the concept we learned in the last class, that is ReentrantLock and Condition, right? So let's go ahead and look into the intuition of it. So the intuition will be, first you will create a monitor object, right? So how do we create a monitor object for ReentrantLock? We write ReentrantLock, lock equals to new condition, right? Then we'll create three conditions. One will be 0 condition, second will be odd condition, and third will be the even condition. T1, the thread which is responsible for printing 0, will wait on 0 condition queue, right? Similarly, T2 will wait on odd condition queue and T3 will wait on even condition queue, right? What else? So initially what we'll do, we'll give control to T1, right, which is responsible for printing 0, correct? Apart from that, we will make T2 and T3 to wait on their respective queues, right? So if this is odd queue and this is even queue, right? So T2 will be waiting here and T3 will be waiting here, right? And also we have another queue which is 0 condition queue, right? Now what we'll do? Initial control is with T1, right? So T1 will go ahead and acquire this lock on monitor object. After acquiring the lock, we will allow T1 to print 0, right? After printing 0, T1 will go ahead and wait in its condition queue. And it will signal odd, right? It will signal the thread waiting in odd condition queue to go ahead and print the odd number. So T2 will get out of this odd condition queue and T2 will go ahead and print 1, right? After printing 1, what we have to do? We again have to print 0, right? So after printing 1, we will go ahead and again ask T1 to come out of the condition queue, 0 condition queue, and print 0. So T1 will come out and print 0, and at the same time T1 will not T1, T2, and at the same time T2 will go ahead and again wait on odd queue, right? Now for the second time, after printing 0, what will T1 do? T1 will now go ahead and ask the thread waiting in even queue to come and print 2, right? And T1 itself will go and again wait in the condition queue, right? So T3 will now come and T3 will go ahead and print 2, right? So we have to do this alternatively, right? So 0, then 1, then 0, then 2. So what will happen? So first time T1 will ask T2 to come out and print. Second time T1 will ask T3 to come out and print. Third time T1 will again ask T2 to come out and print. And fourth time T1 will again go to T3 and tell the thread to come out and print even numbers, right? So this is how we will do. Now how we will make that alternation? So we'll make that alternation using a variable called a simple variable, turn variable or state variable, right? That will become more clear when we directly write into the code. So you got the intuition what we have to do alternatively, right? So let's go ahead and write the code for this. So let's create a class named ZeroOdd Even, right? This will be our main class, right? Now first of all, what we have to do, we have to create a monitor object. Let's create it. Post that, let's create 3 conditions, right? Condition 0 condition, then we'll go ahead and odd condition, even condition, right? We also have to create a variable n because we want to know the limit till which we want to print, and apart from that there will be a turn variable, or you can say a state variable. We'll initialize it to 0. This will be for managing the alternation between odd even printer, right? How we will do that, we'll see. It is similar to what we did in our odd even printer class, so we'll do that, right? Now what? Now let's create 3 functions. First function will be responsible for printing 0, right? So we'll write public void 0. This will be responsible for printing 0. What it will do? It will start from I equals to 1 and I less than equal to n, right? I plus plus. First thing we have to do is we have to acquire a lock. After acquiring the lock, what we'll do? We'll go ahead and check while our state is not equal to 0, right? So let me write it here. State, when the value of state is 0, that means we have to print 0, right? When the value of state is 1, that means we have to print odd, and when it is 2, that means we have to print even, right? So since this function will be responsible for printing 0, we will check while the state is not equal to 0. If the state is not equal to 0, that means we don't have to print 0. So we'll go ahead and wait on our 0 condition, right? So 0 condition dot await, correct? Now if the value is 0, if the value is actually 0, then we will come out and print 0, right? Done. Now what? Now see this very carefully. Now we'll check if the value of I, if value of I modulo 2 is not equal to 0, right? If value of I is 1, that means we have to print odd number, right? So we'll go ahead and signal the thread waiting on odd condition to come out and print, correct? And also, right, so first we'll change our state from 0 to 1 because we want to print odd number, and we will tell the thread which is waiting on odd condition, will signal that thread to come out of the odd condition queue and print odd number, right? If not, if that is not the case, then what we have to do? Then we have to put state is equal to 2, right? If I equals to 2, that means we have to print even, right? So we'll check, right? So if value of I is even, then we'll change the state to 2. That means we have to print even number, and we'll tell the thread, we'll signal the thread waiting on even condition queue to come out and print signal, correct? Now, okay, we have, let's surround it with try and catch, or it's better rather than here, we'll write try here, right? Try, and put everything inside this try. We will catch exception, right? And this is the very important part. We always have to write finally to release the log, right? This we learned in our last class. Irrespective of whatever function you write, if you are acquiring the log, you have to release the log, right? So this is how you print 0. Now what will happen? A similar thing will happen while we print, let's name it print 0, right? print 0. This will name it print odd. Print odd. For odd, I equals to I plus equals to 2, right? Plus equals to 2, correct? Because if n is equal to 6, there are n by 2. That means how much? There are 3 odd numbers, right? So this loop will run till n by 2 times, right? So we'll go ahead and acquire the lock. When does odd thread prints odd? When state is equal to 1. So when state is not equal to 1, we will go ahead and wait in our odd condition queue, right? So if state is not equal to 1, we'll go ahead and wait in our odd condition queue. If suppose state is equal to 1, then we'll come out and print the value of I, whatever the value of I is here, right? And we don't need to do all this. After this, what we have to do? We have to give control to 0 thread, right? The thread waiting on 0 condition. So we have printed 0, then we have printed 1. After printing 1, we want again 0 to be printed. So thread, whichever thread which is waiting on 0 condition, we will go ahead and signal that thread. But also before that, we'll also have to change the value of state. So value of state will again be equal to 0, right? And similar thing we'll go ahead and do for even printer. So print even, and here what we'll do, we'll start from 2, right? If state is not equal to 2, then we will wait on even condition. And if state is equal to 2, we'll go ahead and print that particular value of I. Again, after printing any even number, we have to give control to the thread waiting on 0 condition queue, right? So we'll wake that up, right? So we'll wake that up, and this will go on till n by 2 times as well, right? So this is done, this is done, this is done. This looks fine. Now let's go ahead and create our main function, right? Main function, we'll write a main method, and in this main method, so we have autocomplete here. What we have here, 0 odd even equals to new 0, will print till let's print till 5, right? And for n equals to 5 initially, we have created a thread. So I mean, this is the same thing. Even if you write like this, lambda function, and then post that, you write 0 odd even dot print 0, then that is the same thing, right? Interrupted, right? So that is also the same thing. So you can either write this for shortcut, or you can use this long form using the lambda function, right? This is done, this is done, this is done, right? So we have started all the 3 threads. From thread 1, we have called print 0 function. Thread 2 is responsible for odd. Thread 3 is responsible for printing even number, right? Our 0 logic, this looks fine. This also looks odd, this also looks fine, and this also looks fine, right? So let's go ahead and run this application. We'll go ahead and run this and see the output. What is our output? 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. Our output is correct. Let's print that in new line. Okay, so print ln and print ln, right? And rerun it. So what is our output? 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. Correct? So this is what we wanted, and we have printed it. For more clarity, to make sure that 0 is printed using the same thread, 1 is printed using, odd numbers are printed using same thread, and even numbers are printed using the same thread, we'll go ahead and print printed by get name, right? Here also we'll go ahead and do printed by get name, and same here, printed by get name, correct? Now let's go ahead and run this again, right? What we got, 0 is printed by thread 0. So all the zeros are printed by thread 0. 1 is printed by thread 1. So all the odd numbers are printed by thread 1, and all the even numbers are printed by thread 2, right? If we go ahead and write 10 here and rerun, right? So 0, 1, 0, 2, 0, 3, 0, 4, 0, 5 till 10, right? You can see all the even numbers are printed by thread 2, all the odd numbers are printed by thread 1 and 0 is only printed by thread 0, right? So I hope this is completely clear. This was just the basics how you can use reentrant lock and condition while solving these types of problem, right? And there is one small homework that I want to give you. Try solving the same problem using semaphores that we learned earlier, right? We have solved using reentrant lock and condition. You try using semaphore as well, right? So I think this problem is completely clear to you, as well as the concept of reentrant lock and condition and how to use them in a practical problem, right? So that's it from this video. Until the next video, stay safe, stay healthy. Bye bye.